We're about to answer the same questions that we answered last class, so that's out there. How are we going to do it? Let's go back to the question from last class. If I'm traveling at 3t squared feet per second over the course of the interval 1 to 5 seconds, how far did I travel? We talked about how if you multiply your velocity over your interval, that what you get is feet. Well, what we learned last class is that your calculator can accumulate. It can add your feet per second up over the interval of seconds and get feet. We learned that the button, the symbol for accumulates to your calculator, is actually an integral. But what this means to your calculator is not antiderivative, which is what it means to you. It means accumulate. We see that the visual representation is accumulation, is area. We found the area here was 124. Did we get this answer without a calculator? Well, the answer is yes. And the way we do it kind of is hinted at us in the symbol that the calculator used. What is the symbol that your calculator uses to accumulate? An integral, which you know of as an antiderivative. Why? Because for hundreds and hundreds of years, thousands of years, as humanity, as humans, we didn't have calculators. We didn't have calculators. But we wanted to find accumulations of things. We wanted to find areas under things. But we did not have time to start adding up a bunch of these. Okay? We needed an alternate approach. In comes Isaac Newton. He makes a connection. And the connection is visible in our sign analysis with its extra length. 3 plus how much we increase gives me 13, right? We understand that an accumulation of a derivative tells me how much my original function x increases. This is b, this is x. This is my derivative, this is my x, my original function. Well, if I could not find this, but I could find these or variations of these. If you don't know what this is because you don't have a calculator and you can't accumulate, but you are able to find this and this, would you tell me what the accumulation of your derivative was over this interval 0 to 4? Tell your neighbors, what would it be? How did you find it? I heard that too. I heard that too. What did they actually say? Now, you understand to get from a position of 6 to a position of -2, you have to go down 8. Many of you just do that just by looking and figuring it out. But in reality, you actually did an operation. You subtracted your future position and your past position. This is displacement. This is my change in my position. This is what the accumulation of my derivative from 0 to 4 was. Now again, this is my derivative. This is not my derivative. This is my original function. Now let me throw something at you. Add in another sine interval somewhere. You have space. Great. What if we got my derivative? I don't really care what's going on here. Who cares? I got 0 and I got 4. I want to find out the accumulation of my derivative. I want to figure out this number. But the best I can do is find some position function that maybe has a c in it. Maybe it's like t squared plus c. Well, my position at time 0 would be c. And I don't know what it is. It's unknown. Maybe I don't have this information. My position at time 4 would be 16 plus c. Are you able to figure out this number here? Tell you names. What would it be? This? Yes. Yo, not having all of our information, but knowing that this value and that value are the same, well, c plus 16 will be 16 plus c. You don't have to know exactly where you are to find how much you change. So, let's go back to the question and let's see if we can figure it out. We have a velocity equation. We know what the answer is supposed to be because we used our calculator and our calculator accumulated, added very quickly because it's a calculator, a bunch of numbers together. We understand that my derivative is positive. We'll talk about how sometimes we don't care about signs of derivatives. We are paying attention to the interval 1 to 5. We are attempting to find out what the accumulation of my derivative is, or how kind of much my position increased. Well, I don't know what this is. I don't have a calculator. I gotta go a roundabout way using my position at time 1 and my position at time 5. Go ahead and find your position function off of your velocity function. Do it. Now, how do you go to x from v? You take your antiderivative. Now, hold the phone. Your position function should be t cubed plus c. That's what it is. That's okay though, because my position at time 1 is 1 plus c. My position at time 5 is 125 plus c. What was the accumulation of your derivative? What was the area under v? Well, we must increase by 124. We just found that number 124 without accumulating it with our calculator. Guys, this is so important, what you just learned, that they call it the fundamental theorem of calculus. Okay? Now, the fundamental theorem of calculus is simple. It connects accumulations and antiderivatives. They're kind of one and the same. It seems like they're not related at all. But in fact, if you want to add up a bunch of stuff, you can actually take an antiderivative to use that and get that answer without really adding up a bunch of stuff. Namely, if you want to accumulate anything, say f prime from A to B. Now, before we do this process, we're going to kind of do it using our sign analysis, because I feel like it just fits with what we've been doing. But the proper technique for finding an accumulation, and again, this means accumulation. Why have they used this for accumulation? Because Newton discovered you would take the antiderivative. You'd have a plus c. You would then, and this is something that you might see in math textbooks or something. We're not going to be doing this, but it's going to be there just for you and I. You then find the change in your antiderivative, which is really your displacement. You realize that the plus c won't matter. And the change in your antiderivative is equal to the accumulation of your derivative. This might not make sense to you, whatever, skip it. Just write down accumulation, you can use an antiderivative. That's why the symbol in your calculator is an integral. Let me show you kind of how we're going to do it so that it makes sense. And then in the future, maybe we'll skip a couple steps. Ready? We're going to do lots of great. I asked you to accumulate the velocity over u. Now, first things first, you understand that the accumulation of a velocity is the same as the accumulation of a derivative, which is giving you a displacement of position, how my position is changing. Here's how we're going to do it. Ready? You're going to throw down a sign. You're going to throw down 0 and 3. If we cared about certain questions, we might do a full sign analysis. But, just like on your quiz, what you should have done for your question number 4, sometimes you don't care about all of the changes. Sometimes you just want to care about how did my velocity, what is my accumulation of my velocity over my inventory? Okay? Cool. You want to find this. I don't know what this is. Well, we realized from last class that if we had positions at 0 and at 3, we can roundabout way find your accumulation. It's a connection between accumulations and antiderivatives. So we need to find our position at time 0 and our position at time 3. You guys are working ahead, great. How do you find your position at 0 and position at 3? We need a position equation. We need an antiderivative. Okay, I take the antiderivative of v. You guys take the antiderivative of v for me. But be careful. Always put a plus c, guys, because sometimes we're going to want to find it and we're going to want to use it. Make sure we take antiderivatives, not derivatives. Great. Make sure we're going in the right direction. Now, if I plugged in 0, I get c. If I plugged in 3, I get 3 plus c. Answer the question, what's the accumulation of your derivative? What is the displacement over the interval? What's the answer? Tell your neighbors what the answer is so I know. Good. All right, good. 3. Now, what did you do? You either said c plus 3 is 3 plus c, or you said, oh, I found my ending position and I subtracted my initial position. Now, what does that 3 mean? Tell your neighbors what that 3 means. What's that 3 mean? I ended up 3 to the right of where I started. Cool. That's fine. All right. Let's do 2 more really quick. Go. Now, hold on. Ready? Ready? Sorry. Forgot one more thing. I just want to show you I like that. That's okay. As long as it's a F-bomb concerning calculus and you're excited for getting the right answer. You know, one of my favorite moments in all of teaching happened this year when a kid dropped it up. We were talking about tangent line approximations, and we had that question where it's like, is the answer 4.123, 4.125, or 4.127? And the kid was like, it's A. It's C. It's A. Like, no, it's C. And then he picks up his paper. He's like, look at the effing graph. And I was just like, really, it's a great moment. Okay? So, wow, I messed up. What are we doing here? 2t minus 2. Yeah, we're still sorry. Boom. What did your calculator do to get this 3? Not what you did. Your calculator summed up a bunch of these. You took an antiderivative. Your calculator knows this button as accumulate. It does a very, very complex numerical process to get your answer. You use Isaac Newton and the connection of accumulations and antiderivatives. Go! Tell me about the accumulation of V equals 2. Use that one second. Not as much as you didn't believe me. Yeah, no calculator. It is right here set. Don't dare. Oh no, that's going to change Okay, so, yo, my signs of my derivative, honestly, I don't know and I don't care because I'm not asked to pay attention to it. My position increasing or decreasing, I don't know right now. I don't care. I'm asked to find my accumulation of my velocity. I'm asked to find my displacement. I'm asked to find integral from 0 to 2 of my derivative. I use the antiderivative. I plug in values. We get 4. We get 2. This is negative 2 plus C. We plug in 0. We get C. What happened? We ended 2 to the left of where we started. We just found the area under this equation from 0 to 2. Really, it's the accumulation. Okay, last one. Do this one really quick. Yeah. Go ahead. I got this. I believe. Oh, she already did 0. Oh my God. Wait. Yeah, we did. That's 2.2. Okay, well, we're about to move on, so you got to go real quick. We're not summarize. Okay. A lot of people use the bathroom during lessons because they want to mentally check out because they're already checked out. That's not it. It's not it. Mental competence. Now, this last one is going to springboard us into the next topic.
Examine the motion.
Wait. Wait. Did you guys get 0? Did you guys get 0? Okay. Now, please. Tell your neighbor, what does that 0 mean? I heard a couple things. Does this 0 mean my object didn't move? No. That's very important. There's stuff that happened here. We had changes of position. There is velocity. I am moving. But over the course of the 3 seconds, I end up back where I started. Okay? Now, if I change, see, what if I told you x of 0 was 4? Would you agree with me that c would turn into 4? Would you change this answer at all? So this is very important. We want the c's to be there. If you know what c is, great, but it doesn't change your displacement. Now, this is where we need to start talking about distance. Distance is total amount traveled. We saw on the last example that my displacement was 0, but we know that we moved. Let's examine how much we moved. That's distance. Now, let's say I did a problem and I did a full movement analysis. Just like many of you did on the quiz, like I asked you to do. When I asked you, hey guys, you can just look from 0 to 2 and plug this into your calculator and you get your answer 1. You could have just used 1, okay? But instead, what did you do is you found your zeros of your derivative. You looked when things were positive and negative. You then split up your intervals to figure out how much you're increasing and how much you're decreasing. Meanwhile, I just got 1. But only one of us can answer the next question. How far did I travel? All I have is this 1. And I just look at that 1, and if I answer I traveled 1, I'm wrong. You guys did all of this. You can answer how far you traveled. How far did you travel? Not 1. 3. What did you do? Well, you said I went to the right 2. I went to the left 1. I kept my positive displacements with my positive velocities positive. I took my negative displacements with my negative velocities. I wanted to make them a positive. My displacement is 1. That means I ended up 1 away from where I started. However, my distance is 3. Because through my motion analysis, I realized, oh, I moved this much, and then I moved that much to end up 1 away from where I started. If you don't have a calculator, you have to do a full motion analysis. If you have a calculator, there's a shortcut. We'll talk about this. All right, let's go to the third example on the previous page where we had our displacement of 0. I love this example where our displacement is 0 because we know we moved. We know our velocity isn't 0. We found our starting position was C. We found our finishing position was C. We found the overall accumulation of my derivative must have been 0. My question now, and that's my displacement. My question now is, what is the distance? What do you have to do? Fill in the rest of your analysis. Oh, I don't have a calculator. How do I figure out points? What do you mean points?
Like 1 to
Don't start plugging in 1, 2, 3, okay? What do you do to analyze your derivative and its signs? You set your derivative equal to 0. Then what? That's a great question.
You factor it.
Go.
No, you don't take the integral. You just set it equal to 0. 3t squared minus 6t equals 0. Take out a 3t squared.
Oh, you have to
Come on. Guys, set your derivative equal to 0. Factor out of 3t. Leaves. Okay, factor out 3t. I got 3t times t minus 2. What is the important value? 2. Please fill out the signs of your derivative. Don't plug in 2. When you plug in 2, you get 0. Sure, you plug in 2.5. You plug in 3, it doesn't matter. You get positives from 2 to 3, you get negatives from 0 to 2. Come on, we've done this so many times. Into the derivative. We're not there. Just don't overthink it in that process. Okay? Stop. Now, this is what we did for the first lesson, okay? We did a sign analysis. We focused on the fact that your position is decreasing and increasing. That tells me I'm moving to the left when my position decreases. I'm moving to the right when my position increases. Great. Day 2 brought us the concept of accumulation. If we had a calculator, hooray! I am typing this into my calculator, I'm typing this into my calculator, and I'm moving on. But we don't have a calculator. But it's okay. This is like the hint. Oh yeah, I need my position equation. I need my antiderivative. My antiderivative was t cubed minus 3t squared plus c. I can find my positions even though I don't know what c is. To know my displacements, to then find my distance. So, I plug in 0, I get c. I plug in 2. I plug in 3, I get c. You guys plug in 2, and then tell me how far I traveled. And tell me what happened. What are we waiting for? Please plug in 2 and please answer the question. Was I right? Alright, ready? We'll do another one, guys. 8 minus 12 plus c is minus 4 plus c. Overall, I end up back where I start. But how did I get there? I subtracted 4, then I added 4. What is my distance traveled? 8. Thank you. Please do it for this one. This one's the easy one. I would like to know the displacement and the distance traveled over these 3 seconds. Okay, you don't have to do that. Go ahead. What is the important zero of your derivative? Go ahead. There's not. No, there would have been -1, +1, and 0. I only cared about 1.
So it's like
Between 0 and 0. Yeah, but up at the top, we take our derivative, which is already given to us. Thank you. Pay attention to what's given to you. You set it equal to 0, you get 1. Do a full sign analysis of your derivative, please, so that you know about your position. And then please, understanding your individual or your overall accumulations, tell me what's the displacements over the interval, what's the distance traveled over the interval. I want 2 different answers. I want a displacement and I want a distance. We'll do another one.
It's 4.
I got 4 and 5. Which is 5? That's 5 or that's 5? What's this?
You mean the displacement is 3?
Oh, it's 3 and 5. 3 and 5? Let me check with
I got 5.
Let me see what's 5. Okay. We took our derivative, we set it equal to 0, we got 1. We plug in some test points to check our signs. I plug in 2, I get positives. I plug in a half, I get a negative. I know that I've stopped at 1. I know my position is decreasing. Then my position is increasing, which means I'm moving left, I'm moving right. We can not do this if we don't have a calculator. So we go the roundabout way. Thank you, Isaac Newton. And we plug in 0 into your position function, 1 into your position function, and 3 into your position function. Getting C at time 0, -1 plus C at time 1, 3 plus C at time 3. Getting that I decreased by 1, I increased by 4. Overall, I end up 3 to the right of where I started, but it took me a total of 5 minutes to get there. Now, wouldn't it be nice? Wouldn't it be nice to be able to check these answers with the calculators that you have in close to you. Now, yes, it's easy and we know a quick way to check. We know a quick way to check my displacement from 0 to 3 is 3. Okay, good. So that's 5. It would be great if I could get the answer 5, but without having to do a full sign analysis. So let's go back to the distance calculator shortcuts. Let's discuss this shortcut. No calculator, we got to do a full motion analysis, we got to do a full derivative analysis, all layers, we got it. Now, the shortcut comes with what you kind of did to find the distance. You took your negative displacements, pay attention, you made them positive. It's like you were thinking about only moving to the right. You took your positive displacements and kept them positive. What is that? That's operation, that thing in math that takes negative things and makes them positive. So takes positive, okay, great. Guys, if you accumulate your speeds, the speeds being the absolute value of your velocity, if you use an absolute value in your accumulation of your derivative, you're getting distance. Don't believe me? Let's go and see. The one problem, guys, about absolute values is they're not easy to just insert. So let's type in 0 to 3. Everybody in your calculator, you need to do this so you know what the absolute value is. Go to math. Go over to num. There's adds. Do it in your calculator. Stop looking. You guys are, I'm breaking up next class again. You're horrible. Math, num, adds. You go to the right.
Okay.
Now, this is inside your integral, not outside. 2x plus 2x minus 2. Big money, no whammies. I should get the answer 5. Boom. Whoa. Hold on a second. I got 5.00002978. Why did I get 5.00002978 when my analysis earlier was just 5? Because Newton's a genius, and your calculator is limited by its numerical process of adding things up. Remember when we did derivatives with calculators? I told you, guys, your calculator does the best it can. You know about the slope equation. Your calculator doesn't know about slope equations. It just uses the slope formula and 2 points really close. Your calculator doesn't know antiderivatives. It knows about adding. This button is adding a bunch of shit together in your calculator. It adds a lot of stuff together. It does the best that it can. We've been swearing. It's okay. Let's keep it rolling.
It's going on.
Everything's going on so far. Everything's going on. 5.000 is your calculator's way to say it's probably 5. Okay? Alright, we've already done a couple more. Go back. Double check your answer. Double check your answer here for 8. Have your calculator add a bunch of stuff together and get 8.
Stop.
From this one, the question you did, that number 8. Get that number 8 in your calculator. The distance from 0 to 3. What about velocity? Get 8 in your calculator. No, for this one, for this one.
Wait, no way. Wait.
Now, you don't get 8. If we accumulate 3t squared minus 6t from 0 to 3, we get 0. We know this because we've done it. Wait, hold on. No, really quickly.
That's really close to 0. Wow.
This is another example of your calculator. Getting close. This is 2.25 e to the negative 13. This is your calculator telling you very close to 0. E to the negative 13th is like 0.0000000. Yo, this is your calculator telling you 0. We're doing a bad job of it. That's displacement. Now let's do distance. Math 9, 0 to 3. Math done abs. Guys, this is how you check your answers. This is how you get your answers from your calculator. This is your shortcuts. But if you don't have a calculator, do your full side analysis. Oh, look, your calculator does the best that it can, but sometimes it's going to be a little off. All right, get out of here.
Are you good? That's Mr. Master, don't worry. I understood. Are you good?